Hello, everyone. Happy New Year. Welcome to the first episode, the first ever meetup for 2022. Can't believe it's already 2022. And by the way, today is birthday for our Thai Everett. So happy birthday from everybody.
Happy
You said you
birthday,
turned
Ty.
22.
Oh yeah, happy birthday,
yeah.
Ty.
Happy birthday.
Yeah.
Who's younger, you or Vitalik?
Vitalik? Gosh, I didn't wear that shirt.
That
today,
old dude.
thankfully.
The old dude called Vitalik. Yeah.
Let's see. Probably I'm younger.
I believe
Probably
Ty's
unless he
younger
was
than
like
Ty.
13 years old when he was doing Ethereum.
Yeah.
Cool. I could imagine you are like 12 when you are doing Bitcoin. So that's good.
Who is
A bit funny.
the question should be who is younger, Vitalik Satoshi Vision or Vitalik Buterin?
I don't know. I don't want to be Vitalik Satoshi Vision. I would rather, I don't know. Sharing a first name with that guy, like it's such a, it's just a very unique name, and I don't know. I don't know if I want to be in the Vitalik club. I think I like my current name, the way it is.
Oh, you can, if you like it, you can keep it. So, Michael, welcome here. Do you want to say a few words for people who may not familiar with your background or what's your role here?
So I yeah, like I said, I'm new to this space, new to sCrypt, like pretty green on it, but Ty invited me here to check it out. And I work with Ty on Project Babbage. I'm sure you guys have heard about Project Babbage.
Of course.
But so yeah, I do design work for Ty with Project Babbage. And I'm really just I'm curious to know a little more about this whole community, you know. So this is me being here as a learning experience. So yeah, I hope to learn some stuff and meet some cool people. That's what I heard would happen. So glad to be here. Yeah.
Okay. You're in the right place. Like Stefan, welcome here. Happy New Year.
Happy New Year, everybody.
Happy
Happy
New
New
Year.
Year.
Hey.
Yeah.
Good to see you.
It's Ty's birthday today. So you just missed it. So.
Ty's birthday.
Birthday, yeah. 22, he just turned.
Oh, it's his birthday. Happy birthday,
No, it's
Birthday,
not
yeah.
my first day. I was gonna say, I think I was here before. That's funny.
Happy birthday, Ty. You're 20,
Oh, yeah.
22.
Yes. Thank you.
Oh, wow.
How's everybody's
So,
holiday been so far?
It's good.
Not great. I'm quarantined, so I'm just stuck in my
Oh.
house.
Oh, bummer.
Okay. Okay.
What region are you in?
I'm in Oregon.
Okay, cool.
Like Southern Oregon.
Same place
they
as where I am,
do-
pretty much.
Yeah.
Yeah, there's nothing to do. I mean, yeah.
Did you travel or something and that's why you're quarantined, or why, or you just got sick and that?
My partner and I, our roommate, tested positive.
Oh,
so-
bummer.
Yeah, kind of a bummer.
Okay.
But
Hope
good
you
luck.
get. Hope you get
I'd like to-
better soon.
yeah, we'll see. I'm getting tested on Saturday, so I can go back to my physical job maybe next week. We'll see. Until then, you know, I get to sit here and learn stuff and make stuff. So I don't know. I'm happy with that.
Not bad.
But
Not bad.
Hey, you don't sound bad. You
Okay.
sound fine. So that's good.
I'm pretty sure I'm a-okay. But who knows? Yeah. Here's hoping.
Okay, cool. Is any because I think for the rest of us we've been here for quite some time, and is anything, what's your overall understanding of, let's say, BSV or sCrypt in particular? Is anything particular you want to know more, and you have questions, anything?
Oh, you're saying,
Yeah,
do I have any
yeah.
questions right off the bat? Not right off the bat. I want to,
Okay.
put in here. Maybe I'll come up with some stuff, as we go.
Okay,
Yeah.
cool.
One of the learning resources that Michael could check out that I think Xiaohui just released was the by example thing.
Mhm. Yeah, that's
Right,
exactly
like-
what I'm
like
going to.
There's some good things on there. I checked it out briefly. And that's actually going to help me because I've been trying to integrate more. I want to get away from op return for Babbage. Like I want a user account to be a single Satoshi token that can get spent whenever the account gets updated, and you can like recover it if there's keys that are lost and all that. And so I've been trying to, it's difficult because I want to be able to compile on the fly,
Okay.
like client side. But that's kind of one of my blockers. But I've been reading through a lot of those things that you kind of made a list of on that website, and I'm hoping to be able to incorporate more tokenized, like minor validated stuff and less op returns into Babbage.
Cool. Yeah, as Ty just mentioned, I think earlier this week we just released this new website. So basically, if you go to our official website. If not, so this is sCrypt.io, right? So I think we're adding a button here, but it's coming up very soon. So if you click, there's a learn by example. So basically it takes you to here by example. So basically this, it follows a lot of other languages. For example, Solidity or JavaScript or Go and Python. So you have this kind of like a very, because for people, a lot of people, they don't want to, at least for me, right? I don't want to read all the documentation because that's kind of tedious. But for me, I want to see something in action and in like a very small code snippet. So I can just, quickly glance and then pretty much copy paste to my code base and then tweak it a little bit. For example, right? If I want to just use if else, right? Like, oh, this is if else. It's not very different from, if else from other examples. So, or I want to see, let's say I want to use an array, right? So I could see how do I define it? How do I access it? So it's very handy. Just something quick for people to quickly look up if they don't want to remember all the language details, which nobody does actually, frankly. For me, I could use this also to just quickly go over this. And then click around. If there's something I don't quite remember, fitting everything in my head all the time, I can just quickly click and see the smallest, almost the smallest code example. So I can just copy and paste and go from there. So if you have not,
quick reference.
Yes. So if you've not tried this, and please go there and take a very quick look. I think you'll be. It could be very useful. I think Kevin, you also helped to click around, and thanks for reporting a few bugs, which I think we have fixed. So that's
There's just a few typos. Oh, did you add a bunch of stuff at the bottom?
Yeah,
I didn't see that the first time. Oh, cool.
Yeah, we just added this yesterday actually. So at the very beginning, we only have the syntax wise, and then we put a few like contract examples there, so people can just quickly also click around and see, let's say, auctions or how to toss a coin, and let's say pay to public hash, right? People want to see quickly what it's like if you just put in sCrypt code. So.
One of the things that I was thinking when I was reading it too, that I haven't said yet, is with the stateful contracts. If you click on that one.
Yeah,
I just needed a little bit more of a understanding, like, at the bottom here where we're making sure that the hashes match. But what I was unclear about is, so that's just checking like the format. Like, what if the counter is now different? How can the hashes match? At the bottom.
Oh,
or I just
the bottom. This basically means that this output is actually coming from the spending transactions output. If you change here, right, then you have a different one. You can change whatever this you want, but then make sure the transaction, when you actually construct the transaction, this counter is actually matched whatever here in a contract. So for example, now you from 0, now you increment it to 1, then make sure in actual output when you create the transaction, right? You have to actually, eventually you're going to create a transaction to spend this contract, right? So whatever value here, make sure it's in the new output. This two has to match. So that's the only way to make sure this one holds, right? Does this make sense?
Not
This is what's,
totally, but
yeah, this is what's let's actually.
I just felt like that might need a little bit more of a explanation, because that's one of the most important things, is being able to save state. But it seems like there's a lot of things that you have to do manually that are a little bit confusing.
Yeah, I had the same experience. I don't know if it is necessarily an issue with a code snippet, but there is a general understanding that I did not have initially, which was about the order of execution of things, because I think that we are used to, with imperative languages, think about the order of execution as happening in a particular way. So when we read through that script code that we're composing, the way that I used to at least initially think about it is, oh, I'm going to make this run this way, but then you kind of have to understand also that this will only execute, you're actually composing the locking script, which will only execute once the contract is spent. So you start your starting conditions is at a particular point. This, what you're looking at composing now, executes when the transaction is spent. So when it is spent, then certain things need to happen. So that little blurb that I just said, which makes sense to me in my mind, I don't know if you guys followed it. That thing I didn't understand, and it is a bit of understanding that sits outside of the code snippet there that happens. So I don't know. Yeah, it's kind of, yeah.
So think
That
about
helps,
this.
that helps a bit, but
Okay. Yeah, let me try to explain it again. Let me know if it's still not clear. So basically, state, right? State, basically you think about, you probably heard about state machines, right? So you have different finite number of states, and then you have a kind of like a transition function, which dictates if you have a state A, you take an input, what's the next step, next state you're going to, correct? And this is all deterministic, right? So basically the contract code is this encode this transition function. So which state I'm in and what's the next state I'm going to. But here, that's the only trick for Bitcoin, not trick, a difference. It doesn't directly compute the next state, because for Bitcoin, the model is more think about like a verifying. It doesn't compute directly. So you have to, when you plug in the code, if it's state 0, if the transition function saying if it's state 0, you have to, the next state is going to state 1, then you have to put this state 1 in the spending transactions output, because that's the only way that this transaction can be can succeed, is valid. Basically meaning you can unlock the locking script here. So go back to this example, right? So let's say this counter, right? The beginning, maybe you put it at 0, that's for example, right? So the state here is 0, right? You are not directly computing the next state. You have to make sure this one actually is 1, because if you put anything here other than 1 here, this last sentence will fail, because the output is different from what this is the, you can think of the transition function, right? So you always increment. Does that make more sense now? Or
it does. I saw it in because I rewatched the video again, and it seemed like you were putting, I don't know if you had to, because it said optional in parentheses, but you were like putting the answer to the function in the, or like when you called the function, you were already giving the function its answer, it seemed.
Yes.
Does that make sense or no? Yeah.
Yes.
And so I was wondering,
you only
well,
verify it.
okay, yeah, you're verifying it. And so that's a little counterintuitive,
Yeah, it's a
I
little bit
think. So
different.
it might need
Once you,
some more explanation.
Would
yes,
it be more?
okay.
You don't have to
efficient
do
with
it now,
minor?
but you don't have to do the explanation now, but I'm just saying that I think it could use some more explanation because this part just didn't make that much sense to me. So that's all.
Stefan, you are about to say something?
Yeah, I wanted to say, would it make more sense to say that the miner verifies, meaning that one of the things, for example, if you go back to your code, to the diagram, the graphic that you had before, which is sort of the interesting thing for me here is state 0. So both the orange, all the orange bits there are composed by the developer. And the developer, the first time that you write the transaction to the blockchain, you have to, that in the script, right, the constructor has this template, and that thing also caught me out. The initial, what is the initial state of that counter? So you have to specify that for the very first time you write the output. And then, of course, when you want to spend the transaction, you basically have to compose the spending transaction to essentially conform to the fact that once the miner validates it, they will look for your initial state plus 1, which the counter did. So you have to increment your spending scripts variable by 1 before you try to spend it. That's at least the sort of the sequence that I had to go through to understand it. By placing the miner outside, thinking that the miner is there, and then thinking of what my role is as a developer, or at least from the user's point of view, what the user has to do. So the user basically, of course, has to create all of the orange bits and then pass them on to the miner.
Awesome.
Yeah, exactly.
Yeah, I mean, it'll make sense if I review it, but I was just saying that when I was going through it, I had to do more research when I got to that part. So if you're trying to have like a super simple learner program for somebody, then you might want to, I don't know,
combined
give better
with,
explanation for the state.
Yeah,
Because that's
check
also
out
one of the most important things. I mean, in the other languages, you don't really have to think about passing in the transaction or any of that kind of stuff. It just saves your state. So there just needs to be better explanation.
Yeah, I think that I 100% agree with you, right? And it is not something that's immediately obvious, but it's also something that I have found extremely hard to explain in a because I did that series of videos for TwoStack, right? And I found that it is not the easiest thing to explain simply because it is so counterintuitive. And I would love to see the absolute simplest explanation that somebody could come up with, because I would probably absolutely adopt that, since it is. I found it really hard to explain that, right? Once I understood it, to try and figure out how to explain it, it was a bit difficult for me also to explain it.
All right. Well, I'll look into it more and stuff. So I think it'll be okay. But I just was trying to give like a 30-second feedback when I was talking about the other stuff.
Okay, cool. Yeah, and I think if you have not seen this, but I have my version here. So that's one. I think I explained this. So
yeah, that's the one I watched. I watched this one again too.
See if that makes more sense.
Number 15.
Yeah. Stateful, yes. So if you have checked this out, also let me know if you have feedback. To put it down here. Or the best case, I mean, you are the original influencer, right? So if you want to make your own version, which is more understandable for regular folks, so that would be even better, right? So
yeah, of course, but I need to understand it. if I
I
don't
also-
understand it, I'm not gonna be able to do it.
Yeah, I also think if we could use some kind of like real world use case, and use that as an example to explain this one, I think that might be better as well. And also, I just want to
Okay.
give a shout out to Stephen. His videos was pretty informative. Like on smart contracts, the sCrypt. I think he's got like 4-part videos. For somebody to just get started, he explains. That was pretty cool, like with actually showing the contract and how it plays, and especially for me, like with opcodes, the being able to see the opcodes and explaining like inputs and outputs, that was really intuitive. That was really helpful. So I think some kind of example, like real world use case examples would definitely help.
Right.
Okay, cool. Good idea. Yeah, for me, because I always play with this, so it's kind of straightforward to me because Bitcoin smart contract is a different model. Basically, is you think about it as a verifier. It doesn't usually it doesn't direct compute stuff, right? For example, you have a function f, right? You have fx equals to y, right? So I think in normal programming language, you just calculate the f inside the language, right? But here's the problem. What if the f is very complex, right? It's usually much easier just to verify. Right? It's like a Bitcoin mining, right? So if you want to find the right nonce to give you 100 leading zeros, it's pretty hard. But once you have that nonce, to check whether it has at least to 100 zeros, right? That's very easy. So you think about Bitcoin as this model. It's just my understanding. It's probably not going to put all the computation in a word on Bitcoin, even at the scales, but it's much easier to put a lot of critical things on top of Bitcoin. You can just simply verify it. So here, this is the model, right? When the state machine, you are not actually driving it, but you are just putting the next expected state into it. Make sure this checks out. Otherwise, that's how it drives the state transition.
Yeah, that makes sense that you're just verifying it. And so if you put that, because otherwise when you're reading that, you're like, oh, this is just like any other programming language. But then when you get to that part, it's like, wait, what am I doing here? Because most of the time in every language, it's just like, I don't know, it's like memory, and it's just kind of, you don't even think about it. It's just there. But now we're passing in some previous transaction, and then we're checking the hashes, and it's like, well, why am I doing this? It's just a little bit it's a big leap in understanding in just one paragraph.
If you go read the Ethereum white paper, right, at the the number, I think it's number 3, they have top 4 reasons why you need Ethereum, because there's something they claim that Bitcoin cannot do. One of them is you cannot maintain state, because UTXO, right, is a one-time thing. You spend it or not, right? There's no persistence. So that's what's needed to use the one-time thing to somehow persist the state. Because for Ethereum, they have the global storage, right, which is like a RAM, right? You can store things, and when you go to the next transaction, it's still there. But for Bitcoin, by default, you don't have, right? You have UTXO, spend it, boom, it's gone, right? There's nothing you can say in the next transaction. The state of the former transaction is gone, it's destroyed, right? So, but how do you build upon this to have persistent state? So that's the trick we play here. That's a so-called a push transaction.
You're passing it. So yeah, you're passing in the previous transaction into the next one. I understand that. And then you have to somehow verify that you actually passed in that, maybe. Is that what we're doing with the hashes at the bottom? I still don't understand the hashes at the bottom.
The hashes in the bottom, basically it's a push transaction, right? So if you know the push transaction, that's a field called hash output.
Hash outputs, okay.
Yeah, this is the hash of the spending transaction outputs put together, right? So how do you know? Because if you don't check this, what would I do? let's say this counter example, you put 0 here, right? I can put 100 here. If you don't check, this contract will still be valid, can be unlocked. Do you see here? If you don't have, basically you comment this out, very easily you can verify, comment this out, and then instead of putting 1, you put anything here, 42, 100, 0, or 22, right? So you will always check out because you're not enforcing it. Does this make sense?
Go
Because
back
you can
to
put
the thing.
anything. Right? You can put anything if you comment this out. You're not enforcing any constraint without this, right?
So maybe one
Okay.
way to think about it, is you need to construct based on the output that exists already, like the old one, right? A hash which will constrain the new output based on updates that have been made, such that the new output satisfies the hash that is being created, if that makes sense. So the new output that you're creating needs to be checked to ensure that it is a valid continuation of the existing token. And in order to check that, we need to check the hash. And there can be valid continuations of the existing token, which have slightly
Is this
different
just me, or?
properties than
Yeah,
the
I
original,
think
when
it's cutting out for me too.
stated of
Completely cut out.
1 or 2 or 3 instead of the counter being
Ty, I think your connection is kind of flaky.
either way, whatever the counter is in the new value, whatever the counter is in the new continuation.
There we go.
I'll turn off my.
Okay.
Okay. Is this better?
Better now.
I presume that people cannot hear me. Hello.
I
Now
can hear
it's
you now.
A little better.
Now,
Okay.
now we can hear you.
I'll keep my video. Okay, I'll keep my video turned off. I think it might my video.
Okay.
Suffering some time
goes.
dilation there, Ty.
What I was saying is that I don't know how much of that you got. Kevin, did you get any of what I had said?
A little bit. Yeah, I got a little bit. I was just because
What is
look,
it?
here's the part. Let me just explain the
I
part that's
apologize.
confusing.
My
No,
internet.
it's all right. I'm just gonna. Yeah, it's okay. I'm just gonna explain to everybody the part that I don't understand. And so it's right here when you actually
okay.
construct an. Let me just talk for a sec, Ty. I don't know. The time delay is kind of. Oh, can you keep that on the screen? Because I'm about to point at it. Okay, so right here when it says construct an output, so you're literally building it right here, and you're putting some random amount in it, and then you're taking the hash of that, and you're comparing it to something that already is within the transaction pre-image. And so my question is, like, anybody, you could put any amounts in this thing. There's like all sorts of different stuff. And so I just don't understand when you take the hash, and maybe I shouldn't be wasting our time and I could figure this out on my own, but just what I'm saying is that from this example, there's not enough really information for me to understand this.
I think that's a prerequisite for this. Do you understand the push transaction technique?
I understand it at a high level, but probably not in depth enough. So maybe I'll review that and then I'll come back and take another look at this so we can talk about other stuff. But because I don't think any of your understanding is going to make me understand that, because so far it's just been more confusing to me.
So yeah, you can play with it. We have this boilerplate, right? So in this code, go there and this is counter this one, right? You can actually change it to, let's say, instead of 2, you put it 3, it should fail. I think we may even have some, you can even add tests for this. And also you have input satoshis. You can also play with this. You basically, when you construct the output, right? You have an output in this, right? So you can change the amount to be a different value put here. This will fail. Because the only constraint here.
Well, what is amount? Amount is the transaction fee, or what is the amount?
No. This is
It's just
the Satoshi amount in the output. The output have 2 parts, right? One is script, and the other is the amount, right? Usually call it amount. How many Satoshis?
Oh, I see. Okay, so there, right there, I had a total misunderstanding about what amount was. So you actually have to say how much you're going to be, how much is in the. I'm just so confused by this whole thing. So I'm gonna take another look at it. And, I need to just review the basics even more, input output, because it's all a mess. So
yeah,
I'll get it. I don't want to waste our time anymore. So
check out the video first. I think that's the most detailed one. If you're not just asking the group, because this is the simplest state. So you pretty much have to understand that to get any stateful contract done, to understand this simplest contract.
So then why are you? Yeah, okay. So pretty much the only thing that you're doing here is this .counter plus plus. That changes the state, but then all the other stuff is just kind of boilerplate that you have to do every time, right?
Yes.
Okay.
This is almost always the same.
Yeah.
So if you look at it, So okay, that's the summary. Basically, you only mutate here. Everything else is like a boilerplate stuff. It's always there. But put here, you can pretty much copy paste. It's just only thing you have to do is to maintain your own state. Basically, your own state machine logic. Put it here. Everything else is, I would say most of the time it's the same.
Cool. All right.
Chao, is there a possibility to give an example of where this can be implemented, like this contract in like some kind of real world scenario? Do you have something in mind that?
Yeah, I mean we have many examples. Let's even go back here, right? So we have you call it application, but for example, right, my personal favorite is this one, the Turing machine, right? So let's go to Turing machine. So have you heard about Turing machine? Like
Yep.
Mm-hmm. Yeah.
So Turing machine, right, is basically you have states and then you also have transitions. But then in addition to this state machine, you also have a tape, right? But let's not focus too much on this. The tape is like input output, right? So and the storage. So basically here, right, you have states, right? You have an internal state here. For example, in this example, you have 1, 2, 3, 4 states, right? So this, you can imagine, for example, in here, right? You have, in this Turing machine, right? You can have, for example, you can have one state here saying, for example, you can have a variable saying, oh, which state I'm in, right? And then once you have the state, you have the Turing machine basically tells you have the transition function. So which state I'm in, and what's the new input, and that determines which next state I'm going to, and also how do I move on the tape. But let's not focus on that right now. Basically, you have a state, you have an input, and then that decides. Basically, this is a whole Turing machine here. You can think of this almost uniquely identified your Turing machine. Turing machine, basically you have a state, you have an input, and then decides which next state you're going to. So this is a very good use case, right? So actually we use this technique and write a simple program, just about less than 100 lines, and then is figures out you can actually build any Turing machine on top of Bitcoin, and by that way we prove, contrary to a lot of either misconception or is propaganda, is actually Turing complete. Right? This is just one example.
So the way I understand it is, so there's a transaction that has an output with a state, say A in the scenario, and then and then it can move to transaction a different state, so B, only if there is another transaction that triggers it. Rather than going forward, it's more like a backward moving, like a Turing machine kind of thing, right? So basically, so that decision is only made when transaction 1 happens, rather than
each transition takes a transaction. So for example, you can see here trigger, right? This is like a very good cool like a animation. Basically each one this gets triggered, that's one transaction. You can think about it that way. So you have a initial state, let's say A, for example, you have a right parenthesis, and then you go to state B. Okay? So this is one transaction takes you there.
So for it to move to state B, that means transaction 1. Somebody needs to create a transaction, like TX1. It's not automatically triggered by TX0, but it's if somebody independently creates transaction 1, that satisfies the original output from transaction 0, and that's when the state moves to B. So it's more of like a different way of triggering. Okay, that makes sense.
Yeah. So if you look at all the blockchains, right, as far as I know, is passive, right? The blockchain the smart contract doesn't execute themselves just by themselves. You have to trigger it from outside world, right? Usually by sending transactions. That's the same thing for Bitcoin, true for Bitcoin, also for Ethereum or whatever the latest trendy hot blockchains are, right? Because that's a model, right? You cannot, let's say even somebody send you money. Let's say Bitcoin transaction, I send you, let's say send you 1 Bitcoin, right? How do you redeem it? You also, it doesn't automatically trigger it. You have to, when you're trying to redeem it, spend it, you have to construct your own transaction, spend it, and then move it to your recipient, right? So this is just one example. I think that's my favorite, but you have many others, right? Once you have state, basically you can do everything Ethereum can do, right? Because for them, it's a giant state machine, right? They only have one state, which is the global state. Everything, if you go to Ethereum, right, it's one state. You put one transaction, it moves to another global state. That's it. So actually this enables you to put any other smart contract on top of Bitcoin, actually.
Xiaohui, am I correct in saying that a difference between the way that Ethereum would do it and the way that Bitcoin would do it would be that in Ethereum, the state transition is computed, both the state is kept on chain and the state transition for that state is also computed on chain within the smart contract. Whereas with Bitcoin, the state is maintained on chain. The state transition is computed off chain, and essentially what happens on chain is just to verify that the state transition is valid.
Correct. I think, that's absolutely correct. And that's great point. Yes.
Yeah, that's pretty, I think that's helpful for me to hear that.
It's just validating the state transitions.
Yeah, I'll watch that back. And then because that's also, because it was confusing when I was watching that video about the stateful contracts, and you're inputting the answer before you called the function. And I'm like, well, what's the point of calling the function if you're going to input the answer? Yeah, but if
Bitcoin provides kind of the integrity on top of that. It makes sure that this transaction will only be valid if the answer is correct. And that's kind of the point of calling the function, is to check, make sure that we're making a transaction which contains a correct answer to the question that is being asked, so to speak, by the locking script, if that makes sense, right? Locking script is saying, well, these funds are locked up until this question is given a valid answer, either a signature from a particular key or the solution to maybe a
Hash puzzle.
Hash puzzle or whatever, yeah. And then we call the function to check the answer and make sure that it's correct.
And also, I
Got it,
think
yeah,
that
so you're
that hash function, it also provides a freedom. So for example, when I'm looking from a real world use case, like say for example, like delivering an item, right? So if I create a job that needs an item to be delivered from here, say, to a different location, it doesn't matter who picks up that item, how he delivers it, what kind of expenses he uses. It doesn't really matter, as long as the item is delivered there. That's all I care. That's
just fulfill the constraints of the locking script, however you're going to do it, right?
Exactly, and that provides freedom for people to make their own like find their own path. And with the hash function, I think that basically those paths can be just hashed out. So just for integrity, like you said, yeah. So absolutely, I think this works perfectly. Yeah, that's really cool.
Yeah, just to pile on this point, I think Stefan just mentioned, I think if you want to look at it visually, right, this is also so-called UTXO model. So in the output, you have 2 parts, right? One is amount, how many Bitcoins there. The second is the locking script, right? You can think about it as a lock, right? Basically, this says, if you want to move the coins in this output, you have to provide the right key to this lock, right? It's like any other physical lock, right? So you have to, let's say you want to open your apartment or your house, right? You need to, that's a lock in your front door. You have to use the right key. You don't want to, anybody with any key, they just come in and then just open your house, right? It's just not that kind of a house. I don't know about your house, but it's my house. I want to make sure not everybody just random can come in and change my code. Yes, you see. So it's the same here. That's also, you can think about the lock, right? It's in abstract model is verifying. Oh, is the key what I'm expecting? That all these interlockings that can match. That's the only way to unlock it to provide the correct key. Right? So same for here, even for state, right? But it's just one application of this model. So you can only give you whether you can unlock, which succeed or not. Right?
So you could say, for example, that the only valid update to the state would be to add 1. So if the current value is 11, then the only valid answer to the lock could be 12. And then you also, on top of having it be 12, you have to make a new one where the only valid answer to the new lock has to be 13. And then inside of that one, it keeps going on. And so you're basically saying, here's a constraint, and the only valid unlocking thing for this one is another lock which contains this other puzzle, right? So you can create this never-ending or possibly even ending. You get it?
Yeah. So when you're doing that example in the counter, you're creating the locking script for the next lock.
Yes.
The only valid answer to the previous lock.
See, that's wow.
The only valid answer to the previous lock is the creation of a new lock, which contains certain other possibly different constraints.
Right. Yeah. You're creating.
And that way, the next time you want to unlock
that makes sense.
Okay.
Yeah, but it's just because when you're calling a function, it's like you're computing something, but you're creating a locking script for the next transaction. Okay. That's
you're
obvious.
validating that it's correct.
Yeah. Okay. That's glad you made it. Okay. Eureka.
And we got all this on video too. So anybody else running through the same
yes.
Yeah, I figured even though it might have been a dumb question that maybe not everybody.
It was a good,
I think that needs to be explored for sure.
Yes.
Good.
And also the other point about the calculation has to be off chain. I don't think it doesn't have to be off chain. It just has to be outside of this particular ecosystem. We can create a completely new UTXO and create those calculations, but it can be still on chain, but not just part of this one, right? Are you saying the calculation has to be off chain? Because we can create another calculation solution and still maintain on chain using UTXO, just not part of this particular state machine kind of thing.
Yes.
Isn't that right? So,
Yes,
that's
totally.
a separate
Totally.
program. Yeah, it doesn't have to be off chain. It can still be on chain with the regular Bitcoin transact using the Bitcoin functionality.
Yes.
Yep. It just isn't part of this particular ecosystem, but it still can be
Yeah,
on chain.
it can be anywhere. Basically,
Mhm.
how do you get the correct result? It is from somewhere, right? It can be, usually it's off chain, but if nobody
However you
can
wanna
stop
do it.
you. Yeah, nobody can stop you if you want to pay extra money. But usually it's more expensive, right? So, but for
Mhm.
whatever reason, maybe for transparency or interoperability, yeah, you can definitely do it.
Mhm. Just like nobody can stop you from chartering a jet in order to deliver one single letter in one single tiny envelope from New York to London. I mean, you can
UPS,
do that
right?
if you want.
Mhm.
You could charter a jet and fly across the Atlantic Ocean to deliver one letter. And so that's the way that I would look at it. But like, yes, you can. I mean, yeah, you can. But like, my thing is like, we have the freedom. You have that freedom, but then
Mhm.
like, why? You could. And some people probably will, and some people probably already have, but it may not be necessary.
This
All I'm
reminds
trying
me.
to say is, like this particular ecosystem will not you will not be able to trace where exactly you got the calculations from. There's that disconnect,
Mhm.
but it can still exist on chain, however you want to
Totally. Totally.
that's
Yeah. Speaking of on chain, like a function running, I think if you have not checked out this article, also there's a way. Basically, you want contract, right? You want to get some result from some other contract, right? That's one way is to, we just for example this stateful counter thing, we can compute it the next state off chain, right? And then putting in the new input, new output, we can check it. That's one way, right? But you can also think about compute if this function you can compute in some other transaction, right? Then which then you incorporate into the current transaction, right? So for example, here we give one simple example, as Samir just mentioned, right? You can also do it. For example, you want to solve some quadratic equation, right? But you don't want to do it in your own contract. What do? You just want to solve this. It's like a function library call, right? For example, I don't know about you, but when I'm doing running my code my own program, I don't usually code all the math libraries, right? For example, you want to solve some math equation, or you want to do some let's say solve some matrix, right? You don't usually write your own version. You call some other libraries, right? So this give you one way to do it. Basically, you can compute this. Let's say the example I give here is you put a quadratic equation, right? Again, you only verify this contract, right? You only verify the x. When you plug in all the x, does this equal 0, right? If that means the x is the correct solution for this equation, correct? And once you have the x, because you can use the all push transaction, you can get access to this one. So from this contract, because each input you can think about is an independent contract, right? Because this is one contract, this is another one. So in this way, you can actually implement library call function, inter contract calls in UTXO model as well. And this way, this is computed, not computed. This is verified in another Bitcoin contract. Does this make sense here? This usually you can do this off chain, right? But as Samir said, you can also sometimes you can do it on chain as well, which in this case also.
Yep, absolutely makes sense.
I'll watch it back. I'll watch it back, and maybe it'll make sense.
Mm-hmm. Yeah, hopefully you can get the. Now you have the. I think today max the day you can understand how do you maintain state, at least for counter. Once you know the counter, you can know anything else, right? Because think about most programs, right? It's just state, translation, functions. You can all games, right? You can think about. You have this
Yeah.
state, and then the players make some moves, you get another state. For example, tic-tac-toe, or let's say you also have game of life, right? It's all state machines in an abstract way.
Yep. But you're not really saving, well, you're just writing locking scripts that require the next state. But
Yes.
then,
Mhm.
yeah, that's one way of saying it.
That seems correct.
The word
Alright.
that I came across this week for this technique for op push TX is a covenant. So it looks like
Yes.
the general within our space, folks refer to this technique as a covenant, and I've not heard it referred to it as that before, which is the idea that the constraint that you put on the spending transaction is called the covenant. Yeah, so I just thought I'd throw the word into the mix, because I feel like the word sort of encapsulates a lot of nuance in it. So if I can just call it a covenant, then I know, okay, I'm talking about restricting the spending transaction in a particular way.
Got it. And when I Google covenant, or actually now I use DuckDuckGo, but when I do that, then it's an agreement is the definition. So a covenant is an agreement. So that kind of makes sense.
Yeah, the BDC boys and BCH boys, they use this term. But I use output transaction because it's more powerful. So covenant is like a subset of push transaction, right? Because push transaction, the preimage contains more information than output. Output is just one field, right? You can also have log time, you can have out points, you can have version number, you can have, you can get all the inputs if you want, right? All the previous transactions, because the out points also. So this is basically to demonstrate why we already win the protocol war, because everything they can do somehow, you need some tricks, but it's all we've been showing, right? Time and time again, you can always do it using a regional protocol. You don't have to change the protocol, because they always want to tinker with the protocol, BDC and BCH, right? And even for this output transaction, right? You can do everything that so-called covenant can do, and even do more, because covenant you can only control the output, right? You need hard fork, but we're showing you don't need that, and it's more flexible, more powerful.
So yeah, Kevin, like what I mentioned before, how we can have one of the constraints in order to open this lock, you have to create a new lock that has certain conditions. You can also have one of the constraints be that you have to have the unlocking transaction contain a certain input, if that makes sense. So the unlocking transaction that unlocks this must also unlock a previous other transaction at the same time, or something like that. So even more constraints than just the just what you have there. I think.
Okay, that was explaining that diagram he was showing earlier. No, okay.
I don't know.
There was like this one where he was talking. Okay.
It might have been. I'm not sure actually.
That's all right. Yeah, so you can require multiple, not just the immediate one that you're in, but you can reference a different unlocking script. Is that what you're saying?
So we can have a lock, right? And like I was saying, how the lock can check that the next transaction makes a new lock.
Okay.
Well, the lock can also check that the next transaction also has an input that unlocks another previous transaction in addition to it, or that the next transaction has a certain version number or has a certain other output. So you can check any aspect of the next transaction. You can say any transaction which unlocks this lock must X, right? And then you can put in the custom version number or custom whatever, and do it that way. If that makes sense. So there's more constraints than simply saying the transaction that unlocks this lock must create another lock, you can also check other aspects of the next transaction. That's just more
Got it,
extensible now.
got it.
That's all I was saying.
Nice. Yeah, it's using op push transaction.
Mm-hmm.
So so with the op push transaction, let's use the counter example. There's a way of going in there and seeing what the previous number was. So it might have been 11, and then you're doing the plus plus and then it's 12, or is there literally, yeah, that must be it. Sorry, I was thinking out loud. So the state, because I was trying to correct when you say you're saving state, because really what we're doing is we're verifying that the state that you input is correct. And so so the state is kind of stored in the counter example. It's kind of stored in the op push transaction data, and then it's also calculated when you do the plus plus in that little snippet of the code. And then that's sort of where the state is stored. And then you're verifying, you're inputting 13, let's say, to verify that all that. Okay, that kind of makes sense. Sorry for thinking out loud, but
yeah, I think what you said seems to make sense.
okay, cool.
And of course, as you rewatch this and stuff, you'll probably be able to get to absorb more of it. I mean, I find myself rewatching.
I think the language, some of the language that we use can be, well, if you don't understand it, it could be misleading. But if you understand it, maybe it's not misleading. But
it's just a matter of removing the ambiguity, I think.
Yeah, exactly.
And I've also
maybe
I've
what we go for it, Samir.
Yeah, I've also found that something that I haven't understood just after a few weeks without even doing anything, it just clicks as more things get added. So yeah, that's what I found, especially with this. Yeah, sorry, Stefan, go ahead.
No, I was just gonna say maybe what we need is a pattern language for Bitcoin, so that we can start essentially do. It's good to have labels. I always found that labeling things is very powerful, and this technique, right, that we're talking about when we talk about, for example, the counter, which places a constraint on the output that the code in the contract must persist in the next output, right? You're essentially saying my code that I write in the first output needs to also be in the second output, and on and on and on and on. That's one pattern. I don't have a name for it, but that's one pattern. Then there are other patterns that Ty just mentioned, which would be for particular things like how to spend other inputs, or how to constrain the spending transaction over inputs, which I also think would be nice. But yeah,
maybe
a
the
collection of
pattern,
these patterns would be good.
Maybe the pattern is called like state propagation or something like that. I don't know what the word should be, but we're propagating. I mean, we're forwarding a UTXO and saying that it must continue as itself in any other future that exists that spends it, right?
Yeah, I'm just saying that a pattern language is probably a good idea. I don't know that I have the time. It's actually a pretty involved thing to do to construct a pattern language for these sorts of things. But I think that it's probably a worthwhile endeavor if somebody wants to go at it.
It would just take a bit of time. You're right. Like I wish I had the time to do that. It would be useful. I could see how it definitely be very useful.
Yeah,
Yeah,
there's definitely a use case for that. Like for some use cases, the output, the end result. For some, you just don't know. It's it could be in a predictable pattern, or it could be some kind of unpredictable pattern. But we just need to maintain, like Ty was mentioning, propagate the state. I think there are definitely use cases for all these three different scenarios. So yeah, makes absolute sense.
Yeah, it's for people who have a programming background, it's very similar to like a recursion. You see what I mean, right? So basically, you are not only doing this one time, but you also have to enforce any future subsequent transaction also have this pattern. So for example, I think I like this is by somebody else who's also learning counter example. So he had this very great diagram, which I wish I could draw, but this is very good. Basically, it says, you see the diagram here, Kevin? Eventually,
I can see it. You might want to, just to make it a little bit easier to read, you might want to just close it out so I can see it. Because right now I can see like the backgrounds. It's very messy. I can see the background through the image itself. If you just close that top layer, and I'll just read it at the bottom.
You mean
there you
like
go.
this?
Yeah, I could read that. Yeah, I could read that. Okay, there we go. There we go. Yeah. Okay, perfect.
So basically, think about the color. It means the same contract template, right? So this is this is the template, right? And then it contains the state 0. So the only way you unlock it, basically you check, right? So if you want to, usually when you spend a UTXO, you cannot constrain how let's say Alice send this money to Bob. Once Bob has it, Alice has no way to control how Bob spends it, right? Let's say I send you 1 Bitcoin. Once you take it,
right,
I have no way to constrain how you spend it, right? That's where the word covenant come in, right? Basically, usually constraint. Oh, if I rent this house to you, is there anything constrained? Let's say, oh, you cannot have party of 5, drinking all day, after 2, something like that, right? Because if I just give it a key, I have no way to control, right? But covenant, basically, you can, in a real world analysis, you can constrain how they spend the money too. So in this way, in this contract, we just put the contract here, because if I just this is just a normal pay to public hash, I can spend this anyway, right? Once I take it, I can put it in, spend it to, let's say, I can send it to Michael, right? For example, I can split it one, like half of the Bitcoin go to Michael, half go to Samir, right? That's fine. But in this way, if I put the correct contract, I can constrain the next output has to be the same locking script, except number increment by 1. So I cannot spend it this way. Or if once I have to 1, I keep going, right? This is recursion, right? All the future spendings has to contain this pattern. Right? Keep going. But of course, you cannot even from 1, if you try to spend it with the same pattern, but we put 3, it also will check, fail. This check is all done by the miners, by the way. I know we're kind of like beating the dead horse, but this is a very important concept. I think a lot of people seem to have the difficulty. I agree. It's
I think people will benefit from having this understood.
Yes.
Yeah.
I already see so many use cases for this. Absolutely.
Yep. So you're just putting a lock on the next use case instead of just giving free reign to whatever you want to do.
Because normally you're free to spend Satoshis however you want, but this is like a glorified color coins almost, because now your coins are being allocated, they're earmarked almost in such a way that you can do what you want within certain conditions, if that makes sense. And so I think that's powerful and compelling. And I have to learn to do this for Babbage contracts, because like imagine if a token was a Babbage user account, right? Like the user can spend their token only when they obviously continue to exist to propagate their state. But like, what if their recovery key needs to change or their password needs to change? That's when they can spend their token. But otherwise, that token is basically just reserved as being for that particular use and nothing else. Or messages inside of an on-chain messaging app, like a conversation can be a token. And when you send a new message to that conversation, you are actually spending forward the token, and then adding something to the end of it, if that makes sense, by adding to the history of that token. Use cases like that, I think, come to mind.
Awesome.
That on-chain conversation thread is actually very interesting, because sorry, I'm kind of going off the tangent now, which is if you think of the double ratchet algorithm for secure comms, right? That's being used in Signal, for example, which basically uses elliptic curve integrated signature. One part of it is elliptic curve Diffie-Hellman, the other part is integrated signatures, I believe. If you can assert the requirement for that inside your sCrypt, then basically that sounds interesting to me. If you could figure out a way to do that for the on-chain messages.
You mean to
Purely.
You mean to designate who is to be the next authorized sender or participant of the conversation, or do you mean to do like a key derivation function such that you can derive a shared secret that only the parties to the conversation have?
Yeah, it's both of those things. You
Okay.
both need to be able to do the key derivation function, and of course it only needs to be locked to the participants in the conversation.
Well, the cool thing about having transaction IDs is that because a transaction spends a previous transaction, which spends a previous transaction, et cetera, every TX ID does not actually have complete control over what the next or what its value will be. I mean, they can grind and like try to get a, but they don't get to use a deterministic value that they already know, like, and try to get the TX ID that is associated with the previous thing that's already known. Because of the way that you reference a coin being spent using its TX ID, and that reference goes all the way back to the Coinbase transaction that created the coin. And realistically, it webs all the way out to a whole bunch of previous things. So what you can do is use the TX ID of the last message in the conversation as you get your X and Y of your EC point, but you can hash that with using an HMAC key of the TX ID of the previous transaction to have a bit of extra entropy for any new key derivations that happen for the particular message being sent this time, if that makes sense. And so that way you're using a different EC, you're using a different shared key each time, but the sort of initialization vector, if you will, which isn't really an initialization vector in this case, but more of an HMAC type key that goes into the derivation, can be used to have unique keys for each message, and therefore get comparable levels of security to something like Open Whisper. What is it? Open Whisper protocol or something like that, whatever Signal is based on. Now the trick there is they have even more security because of these ratchets and things like that. So like you embed the next key in the previous, or a value that can be used to drive the next key in a previous message or something like that, such that you can't go back and compromise everything if you compromise one of the keys. And there's other things there, but that's one idea that I have.
Yeah, because then if it's on chain, right, you're just making the assumption that you have been compromised, basically, which is essentially what the double ratchet protects against. It's protecting against the assumption that your comms are open and that people are able to find some parts of the messages. They really can't. It's going to be really hard for them to do. But based on that assumption, I think that kind of forward secrecy is kind of nice to have, because then you can just do it on chain. It's going to be expensive, because it's going to be expensive though. That's the only thing.
I mean, Convo does a messaging application on chain at the moment, and we don't use double ratchet. We just use a single key for an entire conversation between users. So if one user has one key compromised, then every user who has communicated with that user will have the messages of that conversation compromised. And that's a very low standard of security, but I think it can be done a lot better. And the idea why I had it done like that is just for simplicity, so that I could demonstrate the idea that messages could be exchanged without really attempting to be the most secure about it, because that would add a bunch of complexity and go over people's heads and whatnot. But I think that would be a good application, and I guess using sCrypt to enforce the to create and validate, those ratchets and whatever, to use, I guess it would be public derivation, right? Because there would be similar to like how BIP32 works, right? Where we have the public derivation, where we know what the next public key should be without ever knowing the private key. And then validating and enforcing that in an sCrypt contract in the context of a message conversation token would be kind of the goal there.
Yeah, that's sort of where I was going with that.
Mm-hmm. I mean, I wish I had the time to build that. It would be really amazing.
Okay. How did you? Can you, Stefan? Can you type what is the double ratchet in the Slack thread? Because I've never heard about it. I may want to check it out.
Yeah.
Is a protocol or something, or okay?
Yes, it's a key agreement scheme. So it's basically like Diffie-Hellman. It's a kind of key agreement scheme where you continuously derive a new set of symmetric ciphers for exchanging the next message in a sequence of messages.
Okay. And
with
you
perfect
said
forward secrecy, I think.
okay. You said this is using Signal.
Yeah, Signal
okay.
and a few other messengers use it. Yeah.
Okay. Yeah, good to know. We'll check it out. Okay. Seems okay. Never heard about it. Okay, cool.
Just Stefan. So sorry, I missed some part of, or maybe I didn't understand. So how do you relate that to the on-chain and off-chain you're mentioning? Can you maybe take 5 seconds to explain again what you're trying to say?
Sure. So at a really high level, right, what you achieve with something like the double ratchet is that you have two parties who are trying to perform a secure communication between themselves. And in order for that secure communication to occur, typically what you would do is you would use something like a Diffie-Hellman key exchange to securely exchange a symmetric cipher by which you can basically encrypt the message and also ensure that the message comes back from the party that you're actually communicating with, right? So you would start with a Diffie-Hellman. So the double ratchet is just a way of doing this in a continuous loop with a new key on each iteration of each message. And it has certain assumptions built into it, which, for example, it makes the assumption that the communication is happening over an open channel. So in this case, the open channel could very well just be the blockchain, meaning that each iteration of messages, what I'm saying, it would be interesting to investigate using the double ratchet using the double ratchet as a protocol and the blockchain as the medium to establish a secure store and forward means of communicating with another party.
This I don't know about you, but this sounds very promising hackathon project for the next winner, like a Bitcoin fund. You see what I mean? For anybody who's watching this, it's a free idea, so it's not patented.
Go fork the Convo Messenger code base, and then implement the double ratchet as part of a fork of the Convo Messenger code base. And that could be a really good. I would help you with that if you wanted to do it. It could be fun.
It's called Convo. That is another app.
Yeah,
or
so
something,
Convo Messenger is a demo app. It's like a Babbage app that uses action-oriented programming and whatever, and Bridgeport and NanoStore and all of my technologies. But it's like it's an example. It's open source. It's an on-chain encrypted messaging app between users. Users can make a profile and they can send messages on-chain to one another through Convo, as well as photos. They can send like pictures and everything. And the pictures don't go on-chain, so it doesn't cost like $5 to send a picture. It costs like a very small amount because it uses NanoStore.
Payments, yeah.
And so you can fork Convo and change out the Diffie-Hellman part to use a double ratchet instead. I encourage people to do that, and I will help them do it if they want to make that into a business, because you can make lots of money from building a successful version of that.
Is there like a GitHub repo or somewhere, or
Mhm.
it's a documentation, or can you
Yeah, it's like
send in the Slack?
a.
Send in the Slack channel.
I'll
so
put
we
it in
can-
the. I'll put it in the thread. Yeah.
Yeah.
And you can go to like convo.babbage.systems is the website for it, but I'll put the website and the. Let me find the thread.
Nice.
Um,
Okay.
but yeah, I'll post that.
Cool. Yeah. It's yeah, I would definitely check it out. Seems a lot of people have been trying to, even Craig has been talking this idea for a long time. Basically, how do you make kind of like almost like a decentralized, super secure messaging system? Because a lot of time, right? I mean, if we are talking open, but what if you are, let's say you are negotiating some kind of like a trade deal with your business partner over the another side of a globe? So how do you make sure nobody actually, there's no centralized server that can intercept, and they have the keys to decrypt it. You have to be secret. It kind of reminds
And
me
that's how
of
Convo already works.
Yeah, Baymail.
Mhm.
They start with a similar idea, right? But that's more like an email instead of like an instant message.
Mhm.
Yeah,
I just need to
one of
build.
the cool things about the double ratchet is if you successfully compromised one of the keys, you still have all of the other keys to go, because each exchange back and forth is a new key that is not derivable in the same way that BIP32 keys are.
That's nice. So
There has to be a master key on top, though, right? Isn't that how it works? There's like a there's like a master key that's never actually used, and then each child key that is actually used is derivable from the master key. Stefan?
Oh, I'm going to put my foot in my mouth. I don't want to. I have a cursory understanding of the double ratchet from a long time ago.
I've read about it, but I haven't messed with it very much either.
Yeah, me neither.
Ty, the one
Okay,
that you
time-
mentioned, is it the hierarchical deterministic way of creating keys?
Mhm.
That, yeah, is that same?
That's what
with
Babbage
the-
uses.
Yeah, okay.
It's like BIP32 type derivation. I think it's public, like it's a key derivation function that uses a master and then a child index based on the index of the message or something, if I recall correctly. But it's, like I said, not something I've looked too much into. I know that it's possible, and I know that people can and probably should and will do it. I just haven't had the time.
Okay, cool. Yeah, I think we have already covered a lot of the topic for at this limited time.
You were going to
anything
talk
else,
about you were going to talk about the debugging of on-chain transactions using the IDE, right?
Yeah, sure. Thanks for the reminding. Yeah, let me bring the. So let me share my screen again. So if you go to, so we released this new feature. Basically, if you have any transaction that's already on chain, you can actually almost like deassemble the contract into sCrypt contract. Then, because you already have the login script, you have the unlocking script, you can run through it. I think it's not a lot of time. You just, for example, you want to learn about it, how this opcode works, or you want to, sometimes you have a contract and you deploy it and it fails, right? You want to debug why it fails. So this could be very useful. I think quite some people suggest us to add this feature, so we finally went ahead and did it. So if you want to go to always go to sCrypt.io. So you can go to the user menu. So go to debugger, and how do you launch it? There are different ways. So we add a new way to launch debugger from the transaction command. So let's actually bring it up. Okay, let me open my VS Code. By the way, I just got a new laptop, MacBook. It's
You got the M1?
yes. Okay.
How do you
Working
like it?
so fast. So far, so good. But I still have to experience where it actually makes things noticeably faster. But I thought it was faster, but I tried to compile some things, I built some things. It's I suppose it's a little bit faster, maybe 10%, but I still have to. Maybe I need to run some very heavy computation to notice it, but so far not yet. But
I
everything
don't know.
works. Nothing breaks.
I still think
so far.
ARM is for routers, and not
Oh.
computers.
Okay, it's not breaking.
I'm not sold yet. Okay.
Okay, nothing's breaking yet. But ask Kevin. Yeah, he is more expert into this.
Kevin probably disagrees that ARM is for routers because he likes Apple stuff.
I upgraded from a 2015 iMac to the new. So I went. It was like it could have been anything, and it would have been faster. So it's made a huge difference for me. But yeah, if you have one of the newer ones, maybe not so much.
Probably I'll cling on to my Intel until they stop supporting it. Then I'll have to pry it from my dead hands because I like x86. I want to be able to do boot Windows and all that fun stuff, but we'll see.
Okay, let's come back. So how do you launch it? Basically, you can launch from the command, the VS Code command. For my side, I just
somebody's mic is rubbing up against their.
Yeah, I think
it's
Mike,
are you sending?
Just put it on mute.
Yeah, Michael, probably Michael.
I think you're sending interference, Mike.
Just put your mic on mute.
Yeah,
Mike's mic is.
Can you put him on?
There we go. There we
okay.
go.
Okay.
Thank you.
All right, much better.
Okay, so how do you launch it? Basically, you open the command. For my side, I use the Mac Shift command and P, and then you choose Launch Debugger from Transaction Context, and then it brings you to this panel. Basically, you can choose which network. Let's say I choose testnet, and then you can put the transaction ID or the raw transaction. That's, for example, I go to my favorite block explorer, what's on chain, and then I choose testnet. Let's find some transactions and try this one out. Let's see. Let's just find one, any transaction. Let me put it here.
Does it have to be an sCrypt transaction?
No,
anything.
Anything. So for example, here, I just can choose any random one. I think this probably, okay, this is Coinbase. Let's find something else. Of return. Let's find something else. Let's see how many transactions this have. Okay, so of return. I want to find some I can spend.
It's probably all like crypto fights or one of those.
Yeah, too many op returns, man. Let's see. Give me.
People are gonna start pruning those. It's gonna be
okay.
Fun.
I'll give you something. Just give me a second.
I can use mainnet. That's fine. Let's use mainnet. Easier.
On testnet, probably it's.
Oh man. Okay. Give me one. Oh man. Who's
this is what happens when you have a live demo.
All right. Yeah. Demo God.
I'm gonna post in the chat.
Okay.
Let me post in the chat.
I heard. That's fine. Okay. I can also try a loader. Okay. So let's copy the hash. Let's choose mainnet, push transaction ID. And this is hopefully, this is the input index. Basically, I'll select which contract you want to input. The which input, no, which transaction, and then which input the transaction you want to do. So you can launch debugger. Okay, let's pray. Okay, good. Load it. Okay, so far so good. So basically, this give you unlock. It will auto-generate sCrypt contract because we don't know the original sCrypt code, and probably it's not generated from sCrypt code. So it's going to wrap this inside a. Let me actually enlarge it. Can you guys see this? Make it bigger.
Yeah, I can see.
Yeah. So if I go back to this one, this is the transaction one. Transaction. The first input is probably. Let's click this. It's probably going. Seems like a pay to public hash type of contract because you can see from here. And then it decode this, and then plug in all the parameters. You can see, I can even show. So this seems to be the contract expanding from. You can, now it's wrapped around in an auto-generated sCrypt contract, because we don't know the original script code, right? It may not even come from sCrypt. So it wraps in a so-called inline assembly code.
Okay.
You can also check, this is the locking script. And also you can know the B0 and B1, right? This is you can see it here. This is, I think the first one is the public key, and the second one is the signature. So you can actually step through it, right? If you want, you can step through it and look at how the stack changes right here. So this can help you, as I said, one, you can learn about other people's contract, play with it, and also if something fails, right? For example, when you try to unlock, it doesn't work. So you can also plug in the transaction. In this case, you can either put the transaction or the full transaction serialized in hex version. That's also fine.
Oh, that's interesting. So for the local unlock, did it read that from the on-chain spending conditions?
Yes.
To actually get
Yes.
that back out again? Right.
Yes, the B0 and the B1s. Yeah.
Nice.
You can also give me, you send this transaction, right? Let's see. Like we can also try yours. Stop here. We can try. This is mainnet, right? Testnet.
Mainnet.
Okay, let's.
The cool kids
rewrite
use
it.
mainnet for testing.
Okay, man. You got all the money. So if you accidentally burned, I'm not responsible. That's a disclaimer.
I already burned like 2,000 cents.
Already burned. Oh, that's good. It's not a pay to public hash, right?
It's a kind of pay to public hash.
Yeah, you
but
drop
it's
it
a pay to
at the
public
beginning.
hash. I drop the data on the front. Yeah.
This is the right way to do instead of op return, right? Push data and then op drop it.
Yeah.
So
Yeah.
again, you can find, you can almost like deassemble it, and then you can also see all the live data from on chain too. I think if I plug in, if I go here, let's double check this thing. So you can come here, let's say the script, right? This is the script. Oh, let's actually, so this, you have the unlocking script. You have 3044. So 3044, right? This one. And also the second parameter, 03AC. 03AC. Yeah, it fetches all the, basically you can load the contract and it's unlocking parameters from the blockchain, which you can use it for a lot of other purposes, right? We can also go back. This is the original script, right? So see, so we can also decode it here, exactly here, right? You have drop and then followed by a normal pay to public hash.
Yeah.
Okay. Yeah, this is a demo. And any question or comments so far?
I think it's great.
You mentioned
This is cool.
it looks great. Yeah, you mentioned before though that it could potentially decompile into sCrypt based on some knowledge, but I didn't understand how it would be able to
So
achieve
here's the
that.
thing, right? So if let's actually say this, let's actually play with it. So stop this. I can, let's say, go to demo, right? Demo. Because if the contract, you know the original source code and it's actually compiled from sCrypt, then you can kind of decompile it, right? Because you can compile the contract code you have and then compare it with the sCrypt. No, compare with the raw script on chain. You make sure this does come from compile the original sCrypt, right? It's like a verified contract.
You
Once
would
you
need
verify,
a source map. You need the source map though, right?
Yes. So let's actually play with this. So let's say demo. I want to deploy it. Let's say I deploy it. I think hopefully people, let's say, put the, it's Ty's birthday is 22 and 2022, you are 22. Okay, cool. Okay, let's put 20. So deploy it. Okay, now we have this deployed on testnet. So let's try to do this, but from testnet, and this is the test transaction ID. And instead of auto-generated, I'm going to choose this one from, because I know which one it comes from, right? So in this case, I can just choose the demo. Okay, let's see how this goes. So I can launch the debugger and see what happens. Fails ID. Okay. No, I think this is this correct? I think maybe I put the wrong transaction ID or something. Oh, I think I should be loading this one. Sorry. I think this is the Stefan's one. I think this is the latest. So that's why it reports fails, because what's compiled with whatever on chain does not match. So let's rerun this. And let's see demo got. Okay, what's this? This something's not quite right. Let me deploy again. See what's happening. This.
I'll slaughter a black chicken for the demo gods.
Okay, thanks. That's a huge sacrifice from your side. Let's see. Let me try it again, actually. Stop this. Oh, we have a lot open. I don't know if this is the case. Let's close this off. One more time. Okay. You slide. Okay, you chicken. Let's pray. Debug. Put a new random number. Deploy it. Let's say the transaction deploy here. Come back. Let's open it again. Testnet, transaction ID, its index, demo, launch. It's not, I think, yeah, somehow this contract is somehow I always identify this one. Very strange. CD. Oh, this is deploy, sorry. I should use the one that calls it. Okay, sorry, now I got it. Because this is the kind of founding transaction. So I should come here. I think this should work. So I come here, I call it. Okay, that should do the job. I should call it in this transaction. This is 1133, call it. Okay, now succeed. I think this now should work. Okay, let's pray. Let's deploy. I should use a call transaction, not the deploy. Deploy is just normal pay to public hash. Yeah. Launch. Come on. Okay, now here we go. See this? We just add, right? So now it makes sense.
So it knows where you are.
Yeah, you are spending from the just pay to public hash. So we deploy and then call it. We use the calling transaction ID. Make sense?
Nice.
Okay.
Yeah. This is going to be massively useful, especially if you're trying to debug. I can think of all sorts of problems that I've bumped into in the past.
Yes.
Trying to figure out a complex script, whether or where I mucked it up, right? Nice.
Yeah, this can be either useful if you're not using sCrypt, that's fine. You can debug through sCrypt, raw script. But if you have your own contract, when you want to deploy and it fails, you can also plug in, instead of just transaction ID, because it's not there yet, you can also plug in the raw transaction. Right? Based on the raw hacks, you can also debug in this way. Thanks for the chicken
now?
I think. Yeah, it's available and it's free. So I think the chicken did
help.
It helped, definitely help. I think it's
it was only a chicken NFT. It was only a chicken NFT.
NFT? Okay, that's even better. How does that work? Is one chicken token I can redeem for one real chicken? Or?
No, I rugged the chicken token immediately after this demo ends.
Okay, I should take a picture of it. Yeah. Okay, cool. Anything else? I think hopefully the demo is now I found that it's working. I think usually it doesn't work live. But,
Live demos are very stressful. Yes.
Yeah. Yes.
I tried to do
Yeah,
one
good.
yesterday and it actually failed. So.
You remember Ty when we were doing your project Babbitt at Convo and you tried the first time ever?
Oh.
That was really amazing.
Oh, when
So
we
we-
sent the message. Yeah.
Yeah, between two different Convo apps, and it was the
Mhm.
first time ever doing the demo. It worked, so that was
Mhm.
pretty
Oh,
cool.
it worked. Okay.
That was
Yeah.
good.
There you You must have some very good chicken to sacrifice. I
Mhm.
guess.
And I believe Ty had never done that before, even before that call. He
No,
was-
I
really?
had not. I was just trying to do it off the cuff, and it actually worked. And then I tried to do the same thing yesterday while I was on a call with somebody, and I think Mike was there also. And Bridgeport was just completely broken at that point. No bridge was working because the advertisements that make them available on the chain, basically the mapping between what the bridge ID is and like who is claiming to host it was broken. And so nobody could even do anything. There were no actions that were possible, anything like that. For like an hour. And so I figured out what that was after the call very frantically and I got it fixed. But yeah, live demos are kind of crazy sometimes.
Okay, I'm glad it
But I'm
worked.
glad this worked. I mean, I think that what you've
yeah.
done there is really cool because like being able to find where you are while you're debugging after the fact, based on your source code, like that's an important step, I think.
Okay, cool, guys. If not, I think we can just call it a day and hopefully see you all next week.
Mm-hmm.
All right, sounds good.
You have
So-
something?
Yeah, I have an announcement. So I got official approval from the Bitcoin Association to start in like a meetup here in Boston. So I'm going to start
nice.
setting up for BSV and just educating people and so forth. So we might have more exposure of this space. So here in
Very
Boston, it's an official meetup group. So that's I
Nice.
just got that yesterday. So it's pretty cool.
I'd be
All
happy
right,
to meet up
congrats.
with anybody in the Pacific Northwest as well. I mean,
Mhm.
it would be fun to, we could all meet up in person sometime. If people in the PNW, I'd be down for that too.
Yes.
Just throw it out
Yeah.
there.
I think it's an official meetup group from Bitcoin Association. So you could potentially be an admin on that and probably set up. I can talk to the person who I talked to, just give me the one, and maybe that work as well. But yeah, that was something that was really exciting for me, just to get that approval from the guys.
Cool.
Yeah.
Nice.
Originally, we had this Bitcoin meetup in the San Francisco Bay Area, but the unfortunate thing is, seems like every Bitcoin people is moving away from this. That's a bummer. We'll see.
I don't know.
Yeah.
There might just be an antithetical ideology to the Silicon Valley people, but I'm not sure.
Mhm.
I think like Facebook and Twitter, and like we were trying to do things that are different to them and whatnot. But at the same time, I mean, it's gonna be necessary that we have people in all the locations.
Yes. Yes.
There's lots of good engineers down there. I know that for sure.
Mhm.
Definitely, yeah. I think especially like I want to host, like different places within Boston here, especially around the university area. So,
Mhm.
just college kids and other folks. Just have a lot of intelligence here, especially
Yes.
with a lot of different universities. So it'll be pretty cool just to be around those people. So that was
Okay.
exciting.
Yeah. Good luck. We'll see how many people show up. I think best luck on that. Then get some Harvard, MIT, Boston U, and Northeast people coming. That'd be cool. Okay, congratulations, and best luck in the new year. Same for everybody else. Okay.
Yeah, happy New
Okay.
Year.
All right. With that,
All right.
Thank you,
see you,
guys.
hopefully see you around. Okay.
I'll
Bye-bye.
see you guys next
Good
week.
one. Okay.
See you guys. Bye-bye.
See you. Bye bye.